So this here is the set of doors that I'll be replacing. You can see that they are well and truly rotten, gone, and there's no way I could possibly ever salvage them. They are terrible. You can see one of the key areas where they fail is you've got this vertical piece there between two horizontals. Now if that horizontal was to shrink, it opens up a gap here which allows moisture to get in there, and then it starts to fail. You can also see there's a major fail point right here. Well, that I just poke my finger right through it. It's very, very easy. And so if that gets water into there, it all shrinks and starts to degrade that timber, and it really ruins it pretty quickly. One of the primary reasons why the original doors rotted out is because those doors are completely exposed. There's no canopy above them. So when it rains, those doors do get well and truly drenched. And because I'm not really good on the maintenance of painting them constantly, the water did get into the timber and it remained wet for a long, long time, and it did rot out. So the new doors that I'm going to be making are going to be made out of Victorian ash, which is a timber that I commonly use for most of my projects around here. It's readily available, and it is a very durable timber above ground. It doesn't last very well in ground, but above ground it's pretty good, and so long as I keep the paint up to it, it should be pretty good. So I've got a couple of longer lengths of timber available to me to use for the vertical stiles, and for the shorter rails, the shorter horizontal rails, I'm just going to use my other timber that I've got around here, and I'm going to rip them up into strips, turn them on edge, and then glue them up into panels which have a nice clean face on the external face of the door. And on the internal face, if there's a few defects and whatnot, I can just fill it with putty later on. Alright, so I've gone ahead and marked out all of my mortises after I've cut these to length. I've got this set up on my bench, clamped in my vise, hold fast at the other end. I've got this bit of wood setting a limit stop for my router to set that side of the mortise, and I've got this clamp right on the end of the timber which sets this limit for that side of the mortise. So now I simply plunge in and cut my mortises. The only thing I need to be wary about is because the top mortise, the middle mortise and the bottom mortise is a wedged through mortise and tenon, so the mortise goes all the way through. I'm going to have to plunge in through the top and also in from the bottom. So the fence on my router must always be referencing from the face. And I need to reference that fence off the same edge or same face each time, because if I don't have the router bit set dead center of the stile, if I plunge in from the inside edge and then from the outside edge, it'll be stepped over a little bit. Turned out to be that way anyway, but it is what it is. And this router, I tell you what, this really pissed me off here. Alright, I'm pretty sure I found the problem with my router here. I'm not sure if it'll show up on camera, but do you see how there's a yellow and red wire there? Yeah, that's near all that dust. Perfect. So I just want to flip this over. And I've still got my face to the outside, so I can cut this mortise, and this mortise all the way through. The bottom mortise and the top mortise has a haunched mortise and tenon. I forgot to cut the haunch. So that section there will be all the way through, and this is just a 15mm deep haunch. It stops that lower section of the rail from cupping, and that's pretty much all it does. So at the top, in the middle and at the bottom, the mortise is going to be going all the way through. So at the moment it's just a straight line all the way through. We want to bring it straight where the rail comes in. I want to bring it straight a little bit because that will locate it left and right. And then we want to flare it out. So we're going to end up with something like this, like a big old funnel. So normally what I would do is I'd get a chisel, put it near my mortise, put it on an angle and chisel that wall down on an angle. I'd have a mark that I could eyeball along with, and I'd do it that way. And that gives me a nice square corner. It's all pretty good, but it takes a lot of time, it takes a lot of skill. So I was thinking about it a little bit. What if I just get the router, instead of having it plumb, what if I just kick it on an angle? And then I can just plunge straight in, right? I just used a little block to kick the base plate over on an angle. It worked pretty good. So I've just flared that out by 3.4 degrees, about 50mm deep, which is more than enough. So the tenon's going to come through, and then this last 2 inches or 50mm is going to flare out, and then we're going to put wedges in there, and that's going to lock it in. And so that's never going to be able to come out because this is going to be less wide than that. Makes sense? I like it. Now, because the router bit that I used to create these mortises is only 2 inches long, or about 50mm long, I cut in from the top and also from the bottom, which gives me 100mm of cut-in depth, but my stiles are 137.5mm wide, so there's a 37.5mm web of material between the two mortises on both edges. So I'm just drilling out the guts, and then I'll come through with a chisel and clean up the rest of it nice and smooth. Well, maybe not as smooth as I'd like, but it'll be good enough. You guys probably have a much better view down there than what I have up here. So now I need to put a pretty big rebate on all of those parts there to accept the glass panels later on. Now, I don't like putting my router under a huge amount of strain, so what I'm going to do is I'm going to use my saw to roughly cut the rebate in, and then I'll use the router to finish off the rebate, which gives me a nice clean planed cut rather than a sawn cut. So that way I don't really have to I don't need to sand it, because I really hate sanding and I don't want to sand something that's just going to be painted and covered up later. Alright, so to the astute viewers out there, you might be thinking, Kuffys climb cutting here, he shouldn't be doing that. He even made a video saying that you shouldn't do that. It's true, I did, but I climb cut more often than I conventional cut. So a conventional cut would be going from right of screen to the left. I'm going from the left of screen to right, and in doing so it gives me a very clean cut with no chip out. That's why I do it, but there is a very high risk profile in doing so. Tread carefully. So with those rebates done, I now need to cut the tenons on the end of the rails. Normally I can have this end nice and square, and I simply measure back here and I can make my cut there, make my cut there, and that leaves the shoulder being perfectly plumb, and that would work incredibly well if I was connecting into that mortise there, because it would simply butt up there and there's no gap on the bottom, there's no gap on the top. It would be perfect. But I'm not connecting into that mortise, I'm connecting into this mortise, which now has a stepped shoulder. So when I cut my shoulders, I need to have one here and I need to move across, and then another one up there. And whatever distance I need to move across is the exact same distance as whatever that is there. In this case it's 10mm. But there's a very easy way to measure that, because if I don't get it perfect, what happens is I butt it up there, and let's say I've got a bit of a gap there. I start clamping this up to make sure I get rid of that gap. I can do it. The problem is, you see the obvious problem. I now have a wonky donkey door. This face isn't parallel to that face, and the door is all going to be twisted and mangled. So I need to make sure that the shoulder here matches this step in the shoulder of my tenon. The reason why I'm going to the trouble of creating a stepped shoulder to begin with is that it limits the amount of exposed end grain in the final door. So if I was just to create a square opening for a window and then get a router and put a rebate all around that square edge, at each of the corners there'll be a little bit of exposed end grain, and that's primarily where the original doors failed. It's not because it had exposed end grain, it's just that that's the area that got the water ingress, and that's when it rotted out, and then the rest of the door just went with it, right? So I'm just trying to limit the amount of end grain available. And I certainly hope you were paying attention to what I've done there. I've got one of the rails there which has the step shoulder, and all I've done is offset my tenon shoulders by using that piece. And so whatever that distance is, whether it's 10mm or 9.8mm or 10.4mm, doesn't really matter, because now I know that it's going to be the exact length that I was looking for. Because of the way I've done this rebate and then the width of the tenon, there's an odd little shape left over that I just need to remove somehow. The easiest way to remove it is just with a chisel. It doesn't have to be perfectly accurate, but it does need to be kind of good. At the end of the day, if there's any gap that gets left over, a little bit of silicone will fill it up and no water will get in there afterwards to rot out the doors like my original doors rotted out. That's the hope anyway. So here I am cutting the haunch on the bottom rail of the doors. Now that's a huge amount of material that I'm removing from the tenon. You might think, oh, I'm making the tenon weaker, I'm removing glue surface. But I could keep that tenon to be full width if I wanted to. But then on the very end of the stile, it would create a very small amount of timber, which as soon as you torque that rail even slightly, when you're putting it in, for example, when you're trying to assemble it, you're just going to break that little bit of timber off. And so it's actually very weak to do it that way. By doing it with a haunch tenon like this, super duper strong. If you recall, when I was mortising the stiles with my router, the top mortise, the middle mortise and the bottom mortise is a through wedged mortise and tenon. And I've simply tilted my router over on an angle to create that wedged portion. Now in doing so, the ends of the mortise are still round, so I've got to make sure the ends of the tenon are also round. So I've just got a 1/4 inch round over it. I'm just going to round off the ends. Makes it pretty easy and it's pretty quick. Round hole, round peg. Perfect. The two intermediate rails, the second one and the fourth one, I didn't make that a through mortise and tenon because I just didn't want to cut all the way through the stile. So I'm just cutting these tenons back to be about 50mm long, because they're just there just to support the glass really. They're not really holding the door together. Just a quick bandsawn slot for the wedge. And a quick bandsaw wedge for the slot. Too easy. Alright, so when you weren't looking, I'd done a lot of work to these tenons so that they slip into these mortises relatively easily. And the reason why I've done that is because originally, straight off the machines, it was a very, very tight, beautiful fit. And that would be perfect for a PVA glue such as Type Bond 3, which is what I was originally planning on using. But then I did a little bit of a dry fit and I thought, oh, this is going to take quite some time to get this all together and then get the clamps on. Far too much time that I wouldn't be able to get it done with Type Bond 3. So instead, I'm going to use epoxy to glue this together. And because epoxy, I'm not a big fan of epoxy. It's a glue, but I don't feel that it really adheres to the surface. What I think epoxy does, it actually keys into the surface, so it kind of locks into the surface and it simply can't pull out, but it doesn't actually stick to the surface as well as what PVA does. So what I've done is I've basically loosened all of these joints, so they're not sloppy, but they are a little bit loose. But I've also hit it with a bit of sandpaper across the grain there so that there's a good rough surface so that the epoxy can key into and grab hold of so that it can't pull out. That's what I've done, and obviously behind me I've got a door that I've already glued together, and this is beautiful. So if I can get a matching pair, I'll be so bloody lucky and happy. So let's get this one glued up and see how we go. Let's go. I'll get 1 dollop of this, and then I'll get half a dollop of this, and I look at them and I say, is that about 2 to 1? Or I might need a little bit more of that. That looks about right. Put that on there, put that on there. Now, one of the things you need to know about epoxy is that it sets very, very quickly when there's a lot of epoxy. It's a thermonuclear reaction. I forget what it's called. It's not thermonuclear, but it's pretty close to it. Basically, if I was to put that into a really big blob, it would go off really, really fast. But if I spread it out nice and thin, it'll literally take about an hour, hour and a half to set. So I can still work with it for an hour and a half or so, and I know that I need about 30 minutes to glue this door up. So what I want to do here is basically, when this door is finished, this is going to be a surface that's going to be painted, so that's going to seal that surface. That's going to be painted, that's going to be painted, painted. But inside these joints, obviously I can't get any paint onto it. But what I can do is I can seal it with the glue, which does two things. It seals the surface so that if any water was to get into here, it's not going to be able to get into the timber because the timber is well and truly sealed. And it also works really good to glue the things together, right? So I want to get lots of glue on the tenons. I'm not real worried about squeeze out on this. I also want to get glue up on this edge here, because that's a real problem area. If glue gets into this joint, it's going to get into the end grain. So we want to seal the end grain as much as possible, wherever possible. And in this case, we can use the glue to do that. Now this is the big thing with epoxy. So normally if I was using Type Bond 3, I'd have all that glued up, I'd get some glue inside this mortise and I'd quickly get it assembled, because that stops the air drying out the glue on the surface while I'm gluing up the rest of it. But I know I've got an hour, hour and a half, so I can just let that sit there and I'll get back to that mortise later on. Cool. So I'll go ahead and glue up all these. So this is one of the magic things about epoxy. It lubricates the joint. So normally I would have to hit this with a hammer, but it's going in under its own weight. It is a little bit loose. I've done that deliberately, but that's in there all the way. So easy, huh? And the piece de resistance, this hopefully should slide on super easy. Gravity. See, the glue really does lubricate it. One finger. I shouldn't be able to do this normally, not with PVA. It's about the only good thing about epoxy, I reckon. Come on. Good enough. Alright, you can see that I've got my clamps on the door here, and I've got it all clamped together directly on top of my workbench, which I know is a perfectly flat surface. It's flat across the length, it's flat across the width, and there's no wind or twist through it. So that means the door will be flat across the width, flat across the length, without being twisted, ideally anyway. Now I need to put the wedges into the ends, which is a pretty simple task. But first I'll talk about the clamps. So this is a mortise and tenon construction. There is a tenon and a mortise, and the tenon goes into the mortise up until the point that it hits the shoulder. Once this shoulder and that shoulder come together, that's enough clamping pressure. You don't have to really bear down really hard on these clamps to make sure that that shoulder meets that tenon with a hell of a lot of pressure. You don't need all of that pressure, you simply need those two joints to come together. Once they're together, that's enough. If you put too much pressure on with your clamps, you end up, these stiles will end up wanting to come upwards like that. So this will be flat, and that style will kick up that way, and that style will kick up that way, because your clamping pressure is in the middle of this bar, which is above that surface. And so those styles kick up to try to balance everything out. This is one of the clear signs that the glue actually is very, very lubricating. I shouldn't be able to push this in as hard as what I've done. Normally I'd have to tap that in, but it was pretty easy because it's slippery. That's it. When I cut the length of the stiles, I've cut them a little bit over length, because that way it just gave me that little bit of material right on the end, so that when I was plunging the router to cut the mortises, I had that little bit of material just to balance the edge of the router on. Now that the doors are all assembled, I can cut them back to the right length, which is 2040. It actually ended up being 2037 or something just to fit my door frame, but 2040 is the standard length here in Australia. So I'm not actually sure whether I showed that I've sanded these to be nice and smooth, but if I did, you've just seen it. If I didn't, well, I just sanded it. So now I was thinking about what I need to do next. There's going to be a gap in the middle of these two doors, and that gap at the moment is going to be very, very wide. It's going to be about 10 millimeters. It might be 9 millimeters, it might be 8 millimeters. I'm not too sure what it's going to be. So the best way to figure it out is I could go and make all sorts of measurements and account for walls being out of plumb and whatnot, or I can put the hinges on here now, put these doors out on the door frame and physically measure whatever the gap is. Once I know what the gap is, I'm going to add a filler piece of timber to close that gap up, and then there's still going to be a small gap between the doors. I'm going to put a mushroom cover plate over the front of that, so that stops the wind and the rain and the sun getting through that gap later on. So how'd we go? Not too shabby, not too shabby at all. Now I don't want to hear anyone down in the comments telling me all about how I should have just clear finished these doors. I know, they look really, really good like that, but the house colour scheme is white, so I've got to do white. Pretty lucky. It's pretty close and I don't need to adjust anything. So now I just have to figure out what the width of the gap in the middle is. So I need to make one of those doors a little bit wider, and then I can put a cover plate over the front so it stops that gap. Then I can get everything painted. Yeah, looking good. I like it. So that's the T-moulding or the mushroom stop. That gets glued to the active door in this situation. So that's going to swing open, and then when it swings closed, it's going to close up the gap between the active door and the occasionally active door, the other door that doesn't usually get opened. Now I did film this when I made it, but I noticed my hands were getting really close to the saw blade, and I know that irritates and upsets quite a lot of people here on YouTube. So I've chosen not to put that footage up because I just can't be bothered dealing with the complaints. So it was all safe, all good. I've still got 10 fingers. So on the door that I don't normally open, I'm going to have 2 flush bolts. Now these 2 flush bolts, they have pins that shoot up in the top and the bottom, and that will shoot into the top of the door frame and the bottom of the door sill. And that locks that door into place, and it basically turns this door into a wall, which I can use the other door with the handle to lock onto this, what is now a wall. When I want to open these doors, I simply retract those bolts and I'll be able to open those doors freely. So I took a look at these and I thought that I could have just done this fairly quickly just by putting a fairly deep trench through the end of the door there, and that would have made everything fit. But for some unknown reason, I've decided to leave as much timber on the door as I possibly could, which meant measuring and checking and measuring some more and just removing little bits of timber here and there just to remove everything that was in the way, and anything that wasn't in the way is still on the door. Took me a lot of time to do this. I spent about 2 hours just screwing around fitting these flush bolts, but they really did fit very nicely in the end. I'm quite happy with them. I know a lot of people make a fairly good living out of making these sorts of things, but to me, it really is a labour of love. That's better. It's going to go into there. Seems pretty flash. I like it. So at the moment all of the edges are relatively square, so on the internal edge, on the inside of the door, I've just put a fairly big chamfer on there. That knocks that edge off quite nicely, so there's no splinters, no sharp edges. And of course using a router leaves a round corner in each of the corners. So what I've got there is, that's just a very sharp plane iron that I can rest hard up against the chamfer and simply slide along, and it removes the corner pretty neat and tidy. You just got to be real careful about what you're doing, but if you go too far, it doesn't really matter. You can always bog it up and paint it later, because these are getting painted. Next up, I just need to make some glazing beading, so I've quickly made up a little jig. I've just cut a little shape into a bit of timber, which acts as my jig to taper down these small skinny bits of timber, because it's a little bit dangerous to do it on a saw, but through the thicknesser, safe as houses, and it's nice and easy, relaxing work. It just slides on through and comes out beautiful. And this glazing beading simply sits in front of the glass like that, and like that, with mitered corners all the way around, and it just gets held in there with a couple of nails. So I'll install these glass beading after I've got the doors sanded, painted, the glass installed with silicone behind it, and this just finishes off. It's a little bit of trim, that's about it. It does look like it's holding the glass in there, but the silicone itself will hold the glass in, and this simply makes it look nice. So I've got the back of my workshop here set up as a bit of a spray booth just by using some cardboard sheets. I've got my sprayer, which is new to me. I'm still learning how to do this. So I'm going to put a couple of coats of Bullseye 123 primer, and then as many coats as I need of the Dulux Weather Shield Maxi Flex semi-gloss white paint to make it look nice and white and bright. And for what it's worth, for anyone that values my opinion on anything, this sprayer that I got, I hate it. I hate it so much. I don't mean to be rude to the guys at Wagner, but it's either the tool or it's me. But all I know is after I finished spraying these doors, my entire garage was filled with a mist of paint, and it just covered every single surface in the garage, so that when I swept it up, it was just, I'm just sweeping up all these grey particles and white particles. It was bloody hopeless. I'm sure I've done something wrong here, but I just wasn't happy with it at all. I will use it again. I will make it work next time better, but this time it didn't work well at all. My guess it's the paint viscosity or the air pressure or the something or something or something. Whatever it was, it didn't work good for me. Not bad, not bad. I like it. It's pretty good. So I made a few mistakes here. I've got white silicone that I'm going to run around the edge there, and that's what's going to hold the glass in there. I wish I used clear silicone, and I also wish I used more silicone. They don't leak, but I wish I had more. And the glass that I'm using, they are actually glass shelving panels from IKEA that I simply purchased straight off the shelf. I placed an order on their website, they sent them out to me nice and easily. It's 5mm thick, it's toughened glass, easiest glass order I've ever had to make. Then as I press, you can see it creates a nice clean seal. Now there seems to be a bit of an argument as to whether or not the glass gets installed from the outside or whether it gets installed from the inside. The way that I figure it is that if a really strong gust of wind comes along and tries to push that glass in towards the house, well, it's not going to do very much because it's got a pretty solid bit of timber in behind there with that solid timber rebate, so it won't be able to push that glass in. So that's the way I've done it, and I'm pretty sure that's pretty standard within Australia and probably in most of the civilized world. Perfect, not bad. This is a little bit of weather stripping that goes in a groove that I cut into the back of the mushroom stop, and that will stop the wind and the rain from getting into the house in the gap between the two doors. So I've got the rubber seal in here, and you can see that I can press it down very easily with just one finger. But when I try to press that into the door that entire height, I can't get that to close up. And so now the latch doesn't engage, and I can't push that in hard enough to get it to engage. So what I'm going to have to do, I'm going to take that rubber out and run a trench deeper than what I've already done to accept this rubber so it sits less proud out the front here. I'm going to take that trench another 2.5mm deeper, and hopefully that'll close up that gap and allow me to get the door to latch in there. Well, hopefully this works. Don't judge me on my backyard. I'm a slob, I'm a pig, I know it, I accept it, I don't fight it. Well, here's hoping. Ha! Good. Well, these are the doors that Kuffy built. I hope you like it, I hope you enjoy it. Thanks for watching, and I'll see you in the next video.